At Supercomputing 2005, the Boeing Company, Intel, and SGI came together in a collaborative effort to simulate a potential workflow of a Boeing factory floor using the power of silicon graphics media fusion technology. The Intel booth was home to the virtual factory floor, an actual nose landing gear of the Boeing 777, and a quality engineer. A liaison engineer who helps address airplane-specific manufacturing issues was located in the SGI booth and had high-resolution access to drawings and models of the Boeing 777. At the same time, a supervisor stood by in the Boeing booth to monitor their progress and assist as needed. During the three-way collaboration, the engineers and supervisor could interactively visualize a 66-gigabyte model of the aircraft, access drawings and applications from Boeing's internal network, and view real-time video from each site that was delivered via the network. All of this was brought together using silicon graphics media fusion technology that creates a consistent decision-making context for the team, provides a task-focused, customized view at each location, and allows for shared control of applications.
In the past, whenever you had a meeting, everybody would put a chart on the wall and everybody could look at it, people could point at it, somebody could stand up and say, look at this particular piece of it. What you're trying to do with media fusion is essentially recreate the face-to-face meeting. You want to be able to have everybody seeing and experiencing the same thing. In this case here, it's primarily information about the airplane itself.
The main thing that media fusion allows is the real-time collaborative aspects that allow you to share audio, video, and 3D visualization technology in real time.
Okay, Dane, you're on now.
Oh, excellent. All right. Hiya, Skylar.
Hey, Dane, we got your video feed up on the screen here.
Okay. I think I'm ready to go.
What we're going to be displaying here is some interaction between Skylar and I. So he's going to give you the engineering definition while I show you the actual, what the airplane looks like. I wanted to bring up what a 777 airplane looks like in final assembly.
Okay, Dane, looks like you're at the nose gear there. I'm going to follow you on the 3D model, see if we can kind of recreate each one of these photos and show what it looks like in the 3D model.
Well, when a problem gets reported to engineering, generally the first thing that we do is we go look up each of the drawings that are involved and try and navigate our way through the drawing tree to find which drawings are the ones that apply to a particular part or a particular area of the airplane. You may be looking at one drawing and hoping that it gives you the right view, and sometimes you have to look through several drawings to get different angles of the same part.
Fusion is interesting to me because of all the ability to have these different windows up. It'd be very nice to have stuff that you can interact, be on the same thing at the same time. And then if you need somebody else, you just go grab and pull them into your conversation. Very powerful tool. So I've pulled up the engineering drawing, and you can see right on the end, that's that P40 panel.
All right, Dean, I can't see that quite very well in my view of the drawing here. I'm going to take control of your desktop here for a second and zoom in on that drawing a little bit.
Okay.
So if I pick a box right here, we can zoom in a little closer, maybe even a little bit closer than that.
Sometimes it's not always convenient for the people that you need to consult or work with on a problem to actually come out to the factory and look at the airplane. They may be down at one of our other sites or something like that, and to be able to link them up and to be able to show them video of the problem and to look at the engineering drawings at the same time and to look at the 3D model, I think will be a very useful tool to have.
The big problem when you get to shared audio-visual or shared 3D is that you need immediate response and continuous response to allow both parties to understand the real-time aspects.
If something is interactive, you can understand it. You know, if you pick something up to look at it, you turn it around and you play with it and so on. That's what engineers do. It's a very tactile thing, and you need to provide that same experience with visualization. They need to be able to pick it up and look at it, move it in and out, use parallax to test how things relate to each other. If you can't do that, it's very difficult to understand what's going on.
If I had a guy out on the floor that could give me the visual look, he's got a camera, a picture or something, I can talk to him, say, hey, rotate it, this is what I see. I can pull up the my systems and data, validate once against the other, get a clear understanding of that. I bring in my engineering, just like we did on the demo. Skylar, come take a look. This is what I got. Do you see what I see? Now that we're all looking at this thing, if there's something he wants to see, here, let me zoom in on that. Oh, I get that. Let me put this back. I'll get that. It's great.
That interactivity, that real-time aspect is something that Media Fusion brings to the table that's very difficult to do with other systems.
The possibilities just seem to be endless. Every time you thought about an application or use, your imagination just runs. I don't even know where to start.